Hey everyone and welcome. In this video, I'm going to take a look at Azure Container Apps again, but this time focus on deployment with Bicep and also scaling. In the previous video, we looked at deploying with Azure CLI, and we also looked a little bit more in detail at how Dapr works. Now we're still going to use Dapr, but we're mainly going to focus on the scaling aspects. Now, what are we going to deploy? Well, two apps which are really not related to each other. Just a simple front container app, which will be used to illustrate how to deploy a simple container app using Bicep. And then a somewhat more complex container app that reads messages from a topic on Azure Service Bus, and that also is scaled automatically from 0 to maximum 10 instances based on the number of messages on that topic. Let's see how that works. The starting point is a resource group, RGACA, that already contains a Service Bus namespace. The Service Bus namespace contains a topic. The topic is called mytopic. This was created in advance already. Now, in the gist, in the description of this video, you can find the commands you need to run in order to create this namespace and the topic. In the namespace, you'll find shared access policies, and I'm using here the default root managed shared access key, which has full management capability. Now, what we need is one of these two connection strings. I'm going to use the primary connection string, and that primary connection string is going to be used in two places. It's going to be used in the Dapr configuration because the Dapr application needs to read messages from the topic. And we also need it to configure our scaler. The scaler needs to know how many messages are in or on the topic in order to scale the number of containers that work with that topic. So we need this connection string in two places, and you'll see in a moment where we are going to use that. Before we can deploy our container apps, we need to deploy a log analytics workspace and an Azure Container App environment. Now, this is not a deep dive on Bicep, but in a Bicep file to deploy a log analytics workspace can be as simple as this over here. So this deploys a log analytics workspace with the name of LAACA, right? That's the first thing that we need. Secondly, we need this Azure Container Apps environment. So what you see here is that we deploy a resource of type Microsoft Web and then Cube environments. We give that environment a name. I call it myenv, as in the previous video. And then there are a couple of maybe weird things here. For example, when you deploy such a container app environment, you need to specify in the properties the type managed. Although the Visual Studio editor will not give you that property, it is not really recognized and so on, but it is required because you get an error when you deploy the Bicep file and the type is missing. So we're not enabling an internal load balancer, and what is most important here is that we link our environment to our log analytics workspace. So in the app log configuration, we set the destination to log analytics. It needs to be that text, so destination log analytics. And then in the configuration for log analytics, we specify the customer ID and then the key to write to that workspace. We can retrieve that from the LA resource, right? And that's of course this resource here with that name. The LA resource is our log analytics workspace that we deploy first. With that out of the way, we can focus on the more interesting stuff, and that's deploying container apps. Container apps are resources of type Microsoft.web/container apps. Now you'll see these squiggly lines here, and it says that resource type does not have types available. That's something that will be fixed in the future, and that sadly does mean that you won't get a lot of help when you're typing the configuration that you see over here. So you have to use the docs or other examples on the internet. What you see here is the deployment of the front container app. That's a simple one. It doesn't even use Dapr. So we give it the name front and we deploy it to a location. We use the location of the resource group. In my case, that is North Europe. Now, of course, this kind of resource needs properties, and one of the more important properties is what's the Azure Container App environment? Well, we get the ID of the environment by using the environment resource here, env, and we do env.id to extract the ID of the environment. Now, a container app always has configuration and then a template. In the configuration, we can specify things such as, do we want internal ingress or external ingress? In this case, we want to make the container app available from the outside world. In the template, you specify things like the containers you want to deploy, but also the scaling behavior, and that's important here. I think the containers speaks for itself. We only deploy one container here. Image is just a parameter, and that's an image that we've used in the past. It contains this Go app. We give the container a name, and we specify one environment variable here. In the scale section, you can set minimum and maximum number of replicas. That's similar to the previous video where we did that using the Azure CLI. But what is extra here is that we modify the HTTP scaling behavior by adding a rule to the rules array. In this case, it's a rule with name HTTP rule, and it's the HTTP behavior that we want to modify. And for HTTP, you can, for example, set the concurrent requests that your container supports. Based on the number of requests, the Azure Container App environment will scale out or scale in your container. So you can control, for example, depending on the number of transactions per second or concurrent requests that your container can handle, you can play around with this concurrent request value to modify how the actual HTTP scaling works. Not all container apps will be as simple as the front container app. So let's take a look at a more complex container app that reads messages from a service bus topic. This container app is called pubsub. It's more or less the same in the properties, but we do add extra configuration. So at the same level as ingress, we add secrets. In this case, we add a secret called sbconstr, and the value is retrieved from a parameter as you see here. We'll have to supply that parameter at deployment time, as you'll see later. The template of the container is the same. It's the same Go application that I've used before. And I'm going to switch over or skip over the scaling information and go to the Dapr configuration. Dapr is enabled by just setting enable to true. And because Dapr will need to connect to our app to learn about what topics it should retrieve or connect to at the service bus level, we need to enable the app port. In a moment, I'll show you some code why this is necessary, why you need to tell Dapr it needs to go into your code and retrieve some data from an endpoint. Because you're probably thinking, this thing just reads from a topic, so why does Dapr need to go to your app and need to connect to some endpoint in your app? Well, in a moment, you'll see how that works. The app ID is pubsub. Remember, that's the Dapr ID, so the Dapr application ID. And in the previous video, we basically created a component file. And in the Azure CLI command, we refer to the component to define a component at the Dapr level that tells Dapr, hey, you need to connect to Azure Service Bus to do, for example, retrieving of messages. In this case, with Bicep, we don't have to use such an external file. We can just define the components, and you can have multiple components in the components array here. The components array has only one entry. It's one component with the name of pubsub. The type is pubsub Azure Service Bus. The Dapr documentation contains all the other types that are available. And as always, a component has metadata. In this case, I only want to tell Dapr about how to connect to Service Bus. And we use the same secret with the name sbconstr that was defined earlier in the configuration of this container app. So this is the Dapr config. Now let's take a look why Dapr needs to connect on port 8080 to your app. Here we are in the Go code. Now, one of the ways that Dapr can learn the topics that your application is interested in is by calling an endpoint in your code, which is Dapr subscribe. So when Dapr starts up, and your container has also started, it'll call that endpoint on your container. That's the reason why we had to specify the port 8080 that my container is using. Now, Dapr expects when it calls this endpoint, it expects an array of JSON objects. Now, the method in Go that implements this Dapr subscribe endpoint is this method over here. And indeed, we return this array. We create the array over here, and the array is basically containing only one JSON object, by the way, modeled by this struct over here. And this JSON object contains the following: the pubsub name, which is in my case just pubsub, that's the name of my component. Then the topic that my application is interested in, and then the endpoint that Dapr should post the messages to that it finds in the topic mytopic. So whenever there's a new message, Dapr picks up that message and delivers it via an HTTP post to the /myroute endpoint. Now, in my case, that endpoint is implemented by this method over here, and we basically just log the request body. So that means that in log analytics, we should find something that says received a message. And I also log out the entire body that is posted to the myroute method. So we'll see the entire contents of the message that Dapr has found and pushed to your application. And here you see a visual representation of what we just discussed. I'm not going to go all over it again, just to stress the point here that indeed my Dapr application, or Dapr, needs to be informed that my application is running on port 8080 because it needs to call the Dapr subscribe endpoint to know the topic that my application is interested in, and the route, in this case /myroute, that Dapr has to send messages to. These messages are then checked at the service bus topic level. In this case, the topic is called mytopic. The messages, when they are put on the service bus topic from another Dapr application, they will be wrapped in a cloud events envelope. So it's not the raw message that you send from your application. There's some other metadata as well in that message. These messages are then pushed or posted to the myroute handler over there. It's of course important that your handler returns a 200 OK to acknowledge the fact that the message was accepted. Otherwise, Dapr will try to re-deliver the message to that route. Our application can now retrieve messages from a service bus topic as defined in the Dapr configuration using a component. Now I want to scale the number of containers in my container app depending on the number of messages inside or on that topic. Just as with the HTTP scaler, there's a scale option in my pubsub container app, and I can set min and max replicas. Indeed, when you're scaling on external events, you can also scale to 0, as you see here. Now, the rule I have to create is now not a rule based on the HTTP scaling rules. It's a custom rule. So a custom rule still has a name, but then we use custom over here. Now, custom rules actually correspond to these Keda scalers. So Keda is another project, Kubernetes event-driven autoscaling. It can be used with plain Kubernetes as well, but it also works, as you can see here, with Azure Container Apps. Keda has lots of scalers. If I click on scalers on the website, you'll see that there is a Azure Service Bus scaler. And if you look closely in the trigger specification, you can see indeed that the type matches with the type you see over here. Type is Azure Service Bus. I want to scale based on some topic, messages in a topic. So I should refer to the topic name here and then the name of the topic. You also need a subscription name. The subscription name corresponds to the Dapr ID of the application. So just put pubsub there, that matches with the name of our app ID here. App ID is pubsub. Now, I keep the message count artificially low here to 2 messages, so because I want to see the scaling happening rather fast. The container can handle more than 2 messages concurrently, but we just set this low to make the scaling happen. So we quickly scale to 10, as you'll see in a moment. And of course, I also have to authenticate to Service Bus because Keda needs to know how many messages are in or on that topic. You use this in an auth section here, auth, again with a secret ref that references the secret that we defined a little bit higher. That's this secret, that's our Service Bus connection string. And the trigger parameter is connection. That's maybe a bit weird, but you'll see here, if you go down a bit in the authentication parameters, the connection string authentication should be in a parameter called connection. It's not entirely clear here. This, what you'd have to do here, is not entirely clear from the document you see here in Keda. This is somewhat more specific to Azure Container Apps. But this should be enough to have my containers automatically scale based on the number of messages in the topic. Now it's time to deploy our environment and our container apps from this main Bicep file you see here. Now I put myself in the Bicep folder, as you can see over here, and I have the command. You'll also find that in the gist that you have to run. So it's the as deployment group create command, and then of course we specify the template file that we want to deploy plus our parameter. Remember, we had to set the sbconstr parameter to that Service Bus connection string. So let me just copy this over here, copy this, and then paste it here, and then just press enter, and we'll see what happens here. So normally this should do the deployment in my resource group RGACA. And as we have discussed before, the main Bicep file contains everything, right? So it contains the Log Analytics workspace, it contains the Azure Container Apps environment, and it contains these 2 applications, the front app and then the pubsub app. So all of this stuff should be deployed. I'm going to give it some time, and when it's finished, we'll come back to this. So here we are, deployment is complete. And we'll see, of course, the entire output of the deployment. So everything that was deployed, all the information that you've already seen before as well, is here in the output. If I go to my portal environment, let's just go and take a look at the portal. You'll see in the portal that indeed I have my resource group here, and I have my Log Analytics workspace, my environment, and my 2 container apps, front and pubsub. And if I go to pubsub, just to check that indeed I have a secret with my connection string, and I can show the value over here. That's my Service Bus connection string. I can go to revision management, and in the single revision that we have, we only did 1 deployment. We can take a look at, for example, the scaling information. We have scaling from 0 to 10, and we have indeed here, and I see it still says queue-based, but it should be topic-based auto-scaling, but that's just a rule name. And we see all the metadata as well for this scaler. At the Dapr side, we see that indeed we have a Dapr component called pubsub to read from this Azure Service Bus. So all is fine. Let's now publish some messages to that topic and see what happens at the scaling level. Currently, if I look at the in the overview link over here, you'll see that there is 1 replica. Now, after a while, because there are no messages inside that topic, this will actually scale to 0. Yeah, we'll see that in a moment, but for now, let's try and send a lot of messages to that topic. To send messages to the topic, we can use Dapr on our client computer. We just need to create a component file. You can see that here in the components folder, there's an sb.yaml file, and the component file has a format that looks like this. You'll find that format in the Dapr documentation. So in this case, it's a component that we call SB. It has the type pubsub Azure Service Bus, and it has just 1 piece of metadata, the connection string, of course, to our Service Bus. So what I can do now is I can run a command, that's this one, Dapr run, and I can run this command with the components folder. So the -d gives Dapr the instruction to read the components from that folder, and then just start Dapr on port 3500. Now, as you can see, there is no actual application being run here. We just run Dapr. Normally, you would have here at the end your application, your JavaScript app or your Go app or whatnot. We don't have that now. We just run the Dapr sidecar, so to speak. So let's do that. I'm gonna do Dapr run here. And I have to do this, by the way, I have to watch out. I have to do this from the top folder, not from the Bicep folder. And then let's try this again here. So what happens now is that Dapr starts up and it is ready to accept instructions, for example, to send messages to a topic. To actually send messages, I could write an application that does this, but I can also use the Dapr CLI and then the Dapr publish command. So here you see, for example, the Dapr publish command that publishes a message, just some JSON, name equals Geert. It publishes that to an app ID called pubsubapp, to the pubsub component called SB, and that's the name of our component. And of course, we specify also the topic we'd like to send it to. Now, I'm going to run this with a watch command that every 1/10 of a second is going to send this message. So we're going to use another console here, or a terminal. Just open this here. Let's copy this here and then run this command like that. My client app is now sending lots of messages, and actually in no time the number of replicas has shot up to 10. So you can see that here. Remember, you have to check this at the revision level. So this is the revision, and in the overview of the revision, you can see there that there are 10 replicas. The maximum number of replicas is running here. And now I have actually stopped sending messages and waited a moment for things to cool down. And I'll just use the CLI to check the number of replicas on my revision. So here it goes. And let's see what happens. The number of replicas is indeed now 0. Scaling to 0 works with external events as well. That's all due to or thanks to the Keda project. Before we wrap up, let's take a look at the console logs sent from my pubsub Azure Container App. So I went into Log Analytics and I just selected the Container App console logs table. And I'm just running a query directly on that. I don't do anything else, no filtering, nothing. And what I see as one of my last events or logs that I have written is this one over here. Contains all kinds of data, but it contains also the body. This is captured in body_s. And here you see the actual data that I sent. So from my application on my local PC, I just sent this data. But what Dapr is doing, the Dapr client application running on my PC, it's wrapping this into a cloud events envelope. So we're not just sending this data here, we also get the data content type, an ID for tracing, but also, for example, the source Dapr application that sent the message in the first place. And on my local system, on my local computer, that app is called pubsubapp. So yeah, clear that from the Log Analytics workspace, you can see all the messages that were logged by your container. And that's also how I can see that my application running in Azure, running as an Azure Container App, has successfully received the messages sent to the topic. All right, this is the end of this video. So we've taken a look at how to publish Azure Container Apps using Bicep. We kept the Bicep details to a minimum just to illustrate how that works. And then we focused on creating an app that is using pubsub, where we use a Dapr component to retrieve topics from Azure Service Bus, but we also use a Keda autoscaler together with our container to automatically scale the number of containers that process messages on that topic. I hope you like this and see you again for some other video. Bye bye.